Hello, welcome back to part 3 of lesson 4, ellipse. So in this video, we're going to discuss the elements of an ellipse. The first element of an ellipse, we have the center. So the center is the middle point of the ellipse, similar to the circle. It's just CHK. So in this graphs, so we can find the ellipse, the center of the ellipse here. Okay, here it's C. So at the bottom image, we have it here. So again, it's CHK. The second element of the ellipse is the major axis. So the major axis is the longest segment that runs through the center of the ellipse. It determines the orientation of the ellipse. Either it's horizontal, so just like this, and or vertical, just like the second image here. So the endpoints of the major axis on the ellipse are called vertices. And its notation, so for the notation of the distance from the center to a vertex is letter A or small letter A. So to explain, uh, our major axis for the horizontal is this. So this is the major axis. It's not really accurate, but that's the major axis. So it passes through the foci, the two focus. Okay, passes through the 2 points. And for the vertical, we have this here. Okay, so the endpoints of this major axis, endpoints are called vertices, or in singular, it's just a vertex. Okay, so we can compare an ellipse as you can compare the ellipse to the parabola. It's like two parabolas that they call this intersects or combines. Okay, so there's the vertex here. Okay, supposedly one parabola has a vertex. Okay, then they intersect, then it becomes an ellipse. So it's kind of like that, but it's not really the idea, It's just similar. We can imagine that uh, it's there are two parabolas facing one another. Okay, so we'll call this one as the vertices. Okay, then we have the minor axis. Of course, if we have a major axis, there is a minor axis. So the minor axis is the segment that runs through the center of the ellipse and is perpendicular to the major axis. Okay, so it's the element that runs through the center, similar to the major axis, pero it's perpendicular. Okay, so if this is the major axis, then the minor axis is this one here. So if your major axis is horizontal, your minor axis is vertical. If your major axis is vertical, your minor axis is horizontal. Okay, so if the endpoints of the major axis is called vertex, or the endpoints are called vertices, the endpoints of the minor axis, okay, so this is minor, okay, the endpoints of the minor axis on the ellipse are called co-vertices. Okay, co-vertices. So here is the co-vertex. Another co-vertex is here, then here and here. Okay. So note that the distance from the center to a co-vertex is b. By the way, when we have this distance b, this is referring to the semi-minor axis, okay, or half, x, half of the minor axis. So when we have semi, the word semi, it just means half. So it's a distance here. Okay, it's not the, where's the eraser? Okay, so the distance here. Okay, here, half. Okay, then for the horizontal, this part here, that's the semi-minor axis. For the semi-major axis, okay, it's A. Okay, so the slides a while ago here, this is the uh, semi-major axis. Okay, so that's for minor axis. We have the foci, or in some dictionaries, it's read as foci. Okay, the plural of focus. Okay, so why foci or foci? It's because for ellipse, unlike the parabola, there are two focal point. Okay, two focal point. So this determines the flatness or roundness of the ellipse. So the location of the focal point or the foci determines how flat or round the ellipse. If it's very far, okay, so if it's very far, it means that the ellipse is very stretched or very flat. If it's very near to the center, for example, it's here, okay, so it becomes more rounder. Okay, so to find the focal distance, we simply use this formula. So if you try to recall the focal distance of the parabola, it's P. So it's just P, then simply divide by 4. But for ellipse, it's kind of complicated, just a little complicated, but it's not really that complicated because this is a very familiar formula to you. In fact, you know this formula, you remember your high school, this is an extraction or derivative or from the derivation of the Pythagorean theorem. Okay, so again, from the Pythagorean theorem. So we have C equals square root of A squared minus B squared. So remember that A squared is our, or the A, letter A is our length of the major axis and B is the length of the minor axis. Okay, so we simply get the square root of the difference of the squares of the length of the major axis and the minor axis. Okay, so after getting the focal distance, we can now get the focus or the two foci. Okay, so for F1, we have F1 and F2, H plus minus C, K, if the major axis is horizontal, of course, because just take note na lang that if it's horizontal, it means you're adding at the horizontal part of the point. So we're starting with H and K in our center. So horizontal, major axis is horizontal, so we will add at H. If the major axis is vertical, we will add at K. So we simply add our C, add or subtract C from K, as long as the major axis is vertical, because the movement is vertical. Okay, so that is for our foci. Now, we have the Latera Recta. Okay, so what are Latera Recta? The Latera Recta is the plural term for latus rectum. So remember, in our parabola, we have a latus rectum, singular, but for ellipse, we have two latera recta. Okay, so we have it here. So just remember, always take note that if there is a focus, there will be a latus rectum. Okay, so in conic section, if there is a focus, there will be a latus rectum. So in this case, there are two foci, so there are two latera recta. Okay, so these are chords perpendicular to the major axis and are going through the foci. Their length is just 2b squared over a. So to find the endpoints of the latera recta in the ellipse, simply add and subtract b squared over a to the foci. So we have endpoints here. So take note, line segment. A chord is a line segment. So if it's a line segment, there will be endpoints. So we have an endpoint here, 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 and here. So notation of the endpoint is just L sub a number. It's a point. So for example, we have here L sub 1, this is L sub 2, this will be L sub 3, and this will be L sub 4. Okay, so Latera Recta is important in the formation of the graph of the ellipse because it will serve as the guide for us to connect or draw or sketch the graph. Okay, so notation is just L. And then we have the directrices. Okay, directrices is the plural term for directrix. So in an ellipse, there are two directrices. So this is our directrices here. Okay, so two parallel fixed lines on the outside of an ellipse perpendicular to the major axis. So directrices, just always remember that the directrix is in equation form. Okay, so that's why the answer here, the notations, we have x equals h plus minus a squared over c, or y equals k plus minus a squared over c. So just try to connect basta h, x, okay, it's horizontal. Basta y, k, it's vertical. So if you have a vertical major axis, we are sure that the directrices have the form y equals k. Okay, then we just add and minus a squared over c. Okay, so c is the focal distance, a is the length of the major axis, semi-major axis, length of the semi-major axis. And that's it for the elements of an ellipse. So in the next video, we'll be tackling the standard forms of an ellipse. See you there.